Okay, thank you for everyone that came. Thank you, Michal, for the introduction, and Professor Ben Ezra for putting my picture in the middle of the slide. So we will now go through the program, and I will try not to repeat the bioconvergence definition. I will emphasize some of the things that I have to say about the definition of bioconvergence, but mainly about things that Michal already hinted about, how we are excited, but also have to be cautious and want to make sure that this new technology can make good things rather than bad things. With all the respect to technology, team is everything, and when Professor Ben Ezra hired me, he said that this is a teamwork kind of campus, and now I know he was really saying the truth. I will show you how this program is indeed led by the Faculty of Engineering, but actually it's a combination of all relevant disciplines in the campus. Then I will talk about the vision of the program, and also the vision about the whole field. And then give some examples. I want you to really understand bioconvergence through applications that are already relevant, and some collaborations that we have, and the connection to sustainability, which Professor Ron Milo, I will not steal your part of the slides, but it's like a promo, because for me sustainability is something that I got from home, and we want to have, it's one of the examples that we can actually utilize the new technology for good things. So we have to be very careful with any new technology, but if you're cautious and you're doing respectful professional work, as Michal said, we can make life on Earth better. So before I get to the definition of bioconvergence, I want to ask, can we program life? So the answer is yes. This is an example for E. coli, a bacteria that we have in our gut, but this specific bacteria you don't have in your gut because it was re-engineered. The genetic code of this E. coli is different. So this is a fundamental science proof that we can program life. But we are engineers, so we want to see what can we do with this capability. So the vaccine that most of us got for the COVID is a very good example for synthetic biology or bioconvergence, because unlike previous vaccines, when they started from the lab and it was classical health or biology process, here, the companies that developed the mRNA vaccine, they started from the computer. They got the sequence over the internet. They started as engineers. They designed and simulated everything in the computer. They used AI and all the cutting-edge technologies from classical engineering. And the way of thinking was engineering. And then they picked up the best choices of design, and only then they got into the lab. And the solution is actually synthetic also because of the structure of the mRNA is also not natural. So if I would ask Rafi about bioconvergence, he will think about vaccine, and maybe if you just explain to someone outside after you finish this conference, I heard bioconvergence, he will think of medicine and health. Maybe he can also talk about food and agriculture. But what we claim is that it's everywhere. And the reason is that now biology is not on the side of the problem, it's part of the solution. So when it's part of the solution, the problem could be any problem from any field. So unlike bioengineering, classical bioengineering, which was about solving problem in biology, in health, here we actually get biology and bioengineering into the field of engineering and solutions to any kind of problems. So this is a spoiler for the speaker from the Israeli Innovation Authority. I will not get into the details because Dr. Dana Gurevich will get to the details. But just the basic idea for me with bioconvergence is that you take biotech and all the bioengineering techniques that we have, and we converge them with classical engineering, because if you think of any product that you use, it's a result of integration of many fields together. So the bioengineering as a new engineering field, he has to get support from many other engineering, like electrical engineering, optics, AI. So this is bioconvergence for me. And now about the team. So as I told you, we're leading this program from the electrical engineering faculty, but I specify here 2 examples, but we have many other faculties in the campus that are relevant, and we collaborate both internally and externally, because we believe that if we want to train engineers, system engineers and product managers that are relevant for the industry, they have to have a wide perspective. They have to be able to get deeper into the discipline and engineer the bacteria or the specific biology that they engineer, but they have to have also the right skills and training to be aware of all other disciplines, because we want, as Professor Ben Ezra explained, we want them to build a system and not just a component in the system. I'm just one PI out of many that are relevant in this campus. I will give a few examples. I'm sorry for those that I don't have time to mention. I just give I provide here some examples because I want you to see the directions that we can go. So Dr. Michal, that is leading this Belberg, that is leading this session, is collaborating with the design faculty, Yael Avni, and they think of solutions that combine all those disciplines for real products. Dr. Chen Freeman, that is working with green energy and useful microorganisms. Another example, she will teach biostatistics and bioinformatics, Dr. Naama. And Dr. Ronen Shoshnik, sorry, I'm excited. He's in the US now. He's leading the bioengineering here. So he's also part of this program, and I will mention very briefly Dr. Amos Bardea and Dr. Erez Simoni, which is sick today, so he couldn't make it, and Dr. Yulia Einav, and Dr. Hefzi Ragonas, that will lead the panel later on, so you will see her, and myself. So now about the vision. So the vision is like a table. We have 4 legs for this table. So the first one is about integrative applied research. I think we convinced you that it's integrative and multidisciplinary and from application point of view. Maybe Professor Ramez Daniel will say some things about this during the panel. He's coming from the Technion, and he also grew as an electrical engineer and converged to biology later on. Another thing that we mentioned is bioethics and regulation and cyber biosecurity. Here lies the respectful and things that we have to be aware of to make sure that we don't do bad things. So one of the books that just was published by Professor Dov Greenbaum, he started as bioinformatics. His PhD is bioinformatics, but he's part of the law school of Reichman University. So I was part of writing this book, and we believe that we have to work also with those people, because we want to be relevant for the market. And the company is not only interested in research, in scientific research. Another important element is entrepreneurship and industry. So we have Dr. Neta Agmon, which will speak very soon later on, that is one of the key in the management of allergen. We have also Gita that will come. She's now with her baby, so she will come later. She's a representative of VC in this field. So actually, this is obvious. We want to train people for the industry, so we have to have the industry in our vision. That's the third element. And the last but not least is education and training. So the vision is actually that we start here, you see in the middle of COVID, middle school students, that we help them to run a bioconvergence project for monitoring the quality of water. So we want to start from middle school because we want to get students excited from the age of 10 about this field, or maybe a bit later than 10, and all the way to PhD, and also executive programs for industry and the others. But we start from master, and actually master program is the way to start. You don't start from all the... Yes, I know I have 3 minutes, thank you. So now I'll switch to some examples about the engineering. So we know that trees can be very good and are very powerful. This is a natural example. Another example is that we can mimic the way fleas jump. If you could jump the way a flea jumps, you could reach the highest tower in the world. So they mimic and they develop products based on the capabilities of fleas for other applications. And I want to show you one example about the Israeli Spider-Man. So she's not here now, but Shlomtzi is a CEO and the founder of Civix. Civix actually found that fibers made by spiders are very good for many reasons. And this is an example for synthetic biology because you can't really train spiders. They took the genes from the spider and they designed and adjusted those genes for bacteria and yeast, and now you can produce spider silk in microorganisms. Another example, it's a collaboration with Dr. Ilana Kolodkin and 2 undergrad students that are here with us, Yohanan and Avichai, sorry. So here I give this example because we start from the application. We don't start from E. coli or a bacteria that we know and we work with. We start from the application. The application was corrosion. So we took seawater samples and we started from the application and then we started the project. And what we see is that unlike what people think about corrosion being an electrical chemical process, when you see that the difference between sterilized and non-sterilized water is very significant, so it means that indeed biology plays a big role here. And it's bioconvergence because it's part of the problem, but it's also part of the solution. So if we can control those bacteria, maybe we can prevent or detect the corrosion. Another slide that I will skip because Professor Rachela Popovtzer will tell you much more about this, but this is also bioconvergence. It's about monitoring the quality of air and water using a combination between synthetic biology and electrical engineering. And then we can I can tell you more details about our part later on because I have to run. Now I want to play a game with you. So on the one side you see the biotech technologies, and on the other side some examples from classical engineering fields. So just pick a few from both sides and you will get an application. For example, Professor Shimshon Belkin came up with the detection of landmines using bacteria. So this is an example where you see that you have to when you want to manage such a project, you have to understand biology, but everything else beyond biology is relevant. So this is one example for bioconvergence, and you can play your own later on. I will finish with a blessing from a CEO of Twist Bioscience.
Hi everyone, my name is Emily Proust. I'm the CEO and one of the three co-founders of Twist Bioscience. I'm very sorry I can't be with you today, but I'm very excited about this event. For those of you that don't know, Twist Bioscience makes synthetic DNA, and we enable our customers to change the world with synthetic biology. I have a connection to Israel in 2013. As we were growing Twist, we did an acquisition of a genome compiler, which was a company based in Tel Aviv. And now we have a research center in Tel Aviv with 30 people writing software for us. And I'm super excited about synthetic biology. My view is that it will change the world for the better. It's going to increase the sustainability of our lifestyle, and it will improve the health of the planet. There's just so many opportunities to do great work, and also to do well financially. A lot of the synthetic biology companies have been creating quite a bit of revenue and quite a bit of market cap. And I'm super excited about this new center. My view is that collaboration between institution and industry is extremely important. In academia, often you get the bleeding edge of research, so you get the most innovative, very forward-thinking idea. But then industry can help to bring capital and really push those ideas forward. And so with academia, you get the beginning of an outcome, and then with industry and capital, just bring that at scale. So it can't be one person, it can't be one company. It's really creating an ecosystem, and groups and new institutes like this one being created can really strengthen the ecosystem and make sure that academia and industry work more closely together to get the economic and the sustainability and health impact sooner and better.
I will switch to the next speaker.